The story of the B-36, a true superbomber, begins in the early months of 1941. At the time, the United States was still officially neutral, but actively supporting Great Britain with military supplies. Having survived the evacuation at Dunkirk and showing iron resolve during the Battle of Britain, the British desperately continued to hold off the Nazi war machine. In just a year and a half, Nazi Germany had overrun almost all of continental Europe and was gearing up for a surprise attack on their uneasy ally, the Soviet Union, hoping to quickly finish off the stubborn British right after. Meanwhile, on the other side of the world in the Pacific, the Japanese Empire was rapidly gaining momentum. This Far Eastern ally of the Third Reich was getting bolder and more aggressive, staking its claim for absolute dominance over the entire region. American leadership knew full well that the United States being drawn into the Second World War was only a matter of time. Government officials and Pentagon planners were preparing for even the bleakest scenarios. What if Britain was completely crushed? What if the Soviet Union fell, or worse, formed a lasting alliance with the Nazis? Add unchecked Japanese expansion to the mix, and the United States was looking at the very real risk of falling back to a Fortress America strategy. They could be forced to fight a war in total isolation, separated from their powerful enemies by thousands of miles of ocean. Facing this incredibly dangerous geopolitical and strategic reality, the country desperately needed two things to mount a solid defense and project future offensive power: an exceptionally powerful navy and a long-range strategic bomber force. The military needed aircraft capable of delivering devastating strikes directly at the homelands of their main adversaries. While the United States already had a mighty fleet, a strategic bomber force of that scale still had to be built from scratch. The very first and most critical task was designing and building a massive bomber unlike anything seen before. This aircraft had to take off from bases in the continental United States, cover massive distances, drop its payload on Germany or Japan, and then fly all the way back home. Interestingly enough, this hypothetical crisis the Americans were facing was in many ways very similar to the harsh reality the Soviet Union would eventually face during the Cold War, which pushed Soviet leadership into a frantic race to develop their own intercontinental strategic bombers. On April 11, 1941, the United States Army Air Corps finalized their work and issued a completely new set of requirements to the American aviation industry. This was the design specification for a future intercontinental bomber envisioned as the ultimate deterrent and defender of the nation. At first, the military was asking for an airplane with performance specs that read like pure science fiction. They demanded a bomber with a range of 12,000 miles. On top of that, it needed to cruise at 275 miles per hour at an altitude of 25,000 feet, with a top speed hitting 450 miles per hour. The combat ceiling over the target area had to be an unbelievable 45,000 feet. For early 1941, these demands seemed completely out of touch with reality, pushing the absolute boundaries of aerospace engineering. To give you an idea of the scale, the most advanced mass-produced American bomber at the time, the B-17 Flying Fortress, had a maximum range of only about 2,000 miles and fell way short in both top speed and payload. Right from the start, the new aircraft was designed specifically as an intercontinental strategic bomber. Its main job was to take off directly from the United States and destroy high-value targets on other continents. Given this mission, its practical combat radius had to be anywhere from 3,700 to 4,350 miles. With a range like that, fleets of these bombers could easily reach any point in Europe. If they were stationed at forward air bases in Canada, Alaska, Hawaii, or the Philippines, virtually any target on the Asian continent would fall within striking distance. For shorter range missions where the combat radius decreased, the bomber was expected to carry a massive payload of up to 72,000 pounds. The military's vision also went beyond just bombing missions. Technical requirements called for a dedicated strategic photo reconnaissance variant, and plans emerged to develop an aerial tanker version meant to refuel other aircraft in mid-air, massively expanding the reach of the entire fleet. By August 1941, the military's initially overambitious requirements for the new superbomber were dialed back to reality. The concept was boiled down to a simple metric: the Army needed a bomber capable of flying 10,000 miles while carrying a 10,000-pound payload. To hit these numbers, engineers envisioned an aircraft essentially 4 times the size of the familiar B-17. Under these revised specs, the Giant's maximum range was set at 10,000 miles, with a combat radius pegged at 4,000 miles. It also had to maintain a cruising speed between 240 and 300 miles per hour, with a target service ceiling of 40,000 feet over enemy territory. Shortly after the Army Air Forces issued their requirements, heavyweights of the aviation industry, including Consolidated, Boeing, Douglas, and Northrop, stepped up. By October 1941, engineers had submitted their preliminary designs, and Consolidated ultimately won the intense competition, having already started designing their Giant months earlier in May. Their concept was incredibly ambitious. They proposed a massive aircraft powered by 6 engines buried entirely within the wing, featuring a twin tail and pusher propellers that gave the aircraft a highly futuristic look. In mid-November, Consolidated received an official contract to build 2 experimental prototypes of the long-range bomber, officially designated the XB-36. The first prototype was scheduled to take to the skies by May 1944, with the second following in October. At the request of the military, designers also explored an alternative configuration powered by just 4 engines mounted in dual nacelles, but that idea never made it off the drawing board. When the United States entered World War II, military priorities shifted drastically. All focus turned to mass-producing the proven B-17 and B-24 heavy bombers, while the advanced B-29 was rushed into production as quickly as possible. As a result, development of the massive B-36 took a back seat, proceeding at a slow, almost peacetime pace. Throughout 1942, engineers intermittently tested scale models in wind tunnels, and by late summer, they completed a full-scale mock-up at the plant in Fort Worth. The designers constantly tweaked the aircraft, drawing heavily on the operational use of B-24s and British heavy bombers. In 1943, they ditched the twin-tail configuration in favor of a conventional single vertical tail. Powering this Giant were massive Pratt & Whitney R-4360 Wasp major engines. Thanks to twin turbochargers, each engine could generate an impressive 3,000 horsepower up to an altitude of 34,500 feet, spinning highly efficient 3-bladed Curtiss propellers. Creating an aircraft of this scale was a massive challenge. It featured an extreme takeoff weight, an enormous fuselage with pressurized crew compartments, a massive wingspan with integral fuel tanks, and an incredibly complex defensive system. Drawing on the harsh realities of the war, they decided to give the bomber an unprecedented level of defensive firepower, far exceeding that of the B-17 or B-24. Designers originally planned to mount 37mm cannons, and the number of heavy machine guns was bumped up to 15 across 4 firing positions. In the nose section alone, they planned a dual 37mm turret, with the tail section protected by another identical twin-gun turret paired with 2 50-caliber machine guns. It was not until mid-1943 that the military and engineers finally locked in the basic specs for the future B-36. The specifications were unprecedented. Maximum range was projected at an incredible 10,000 miles, with an empty weight of around 128,000 pounds, and a massive maximum takeoff weight hitting 264,500 pounds. The crew consisted of 11 men, with full tanks holding 18,750 gallons of fuel. The bomber could carry 20 500-pound bombs in its weapons bays. If the payload was increased to 72 1,000-pound bombs, the fuel supply had to be cut down to 9,000 gallons, dropping the range to 4,660 miles. As for speed, this Giant was expected to hit 285 miles per hour at sea level, 365 miles per hour at 29,500 feet, and cruise at 240 miles per hour, with a combat ceiling of nearly 39,700 feet. During development, these ambitious targets were adjusted more than once, such as when they decided to install a more advanced version of the R-4360 engines in August 1945. By mid-1943, Allied planners came to a grim conclusion. Effectively bombing the Japanese home islands with existing long-range bombers was not going to work. Even factoring in the upcoming arrival of brand-new B-29 superfortresses operating from airfields in China, they would still be relying on bases located too far from Japan. Because of this, there was a desperate need to accelerate the ambitious B-36 project. On June 19, 1943, General Henry Arnold ordered the immediate purchase of 100 bombers, and by July 23, Consolidated Vultee, or Convair, officially received this massive contract. However, when American forces secured the Mariana Islands and built a massive network of airbases there, the B-29s proved entirely up to the task of striking Japan. The urgent need for the B-36 temporarily dropped off, shifting development into low gear, which is why they had not managed to finish even the first experimental prototype by the end of World War II. After the fighting in Europe finally ended, the U.S. began a massive review of its military contracts. Many weapons programs were slashed or canceled, but the contract for the B-36 remained intact, confirmed at the highest levels. Moving forward, the U.S. Air Force planned to stand up an entirely new organization, the Strategic Air Command, or SAC, where 4 bomber groups fully equipped with these new giants would be assigned. Earning the unofficial nickname Peacemaker, this bomber was assigned the role of America's global long arm. According to political and military leadership, carrying a nuclear payload in its grasp was one of the most important and convincing arguments for defending U.S. strategic interests in the post-war world, serving as the ultimate stick in America's Cold War diplomacy. By August 1945, the first experimental prototype, officially designated the XB-36, was being assembled at the Convair plant in Fort Worth. At that time, it was only 82% complete. On September 8th, this still unfinished airplane was carefully rolled into an experimental hangar, lacking a full set of systems, missing specialized equipment, and most importantly, without its engines. The biggest engineering hurdle was the power plants. It took Pratt & Whitney 5 solid years of painstaking work to get their horsepower output, high-altitude performance, and overall reliability up to a standard where they could safely power this unique airplane. Finally, on June 12, 1946, engine installation and extensive ground testing began. After initial taxi tests in July, the historic moment arrived on August 8, 1946. A 9-man crew led by veteran test pilot Beryl Erickson took the XB-36 into the sky for the very first time. This maiden flight lasted exactly 37 minutes, with the bomber tipping the scales at a gross takeoff weight of 198,000 pounds, carrying over 7,900 gallons of fuel. All told, a full 5 years and 3 months had passed from the start of the project to the prototype's first flight. For its time, the B-36 was a true engineering marvel, years ahead of the curve in aviation design. Imagine a massive, all-metal aircraft featuring a high-mounted wing. Powering this giant were 6 massive piston engines buried inside the wings, driving huge 3-bladed pusher propellers that pushed the airplane forward rather than pulling it. Why did the B-36 look the way it did? It all came down to covering intercontinental distances while carrying a massive payload. Practical jet or turboprop engines were completely out of the question back then. Engineers realized that only tried and true piston engines could deliver the required fuel efficiency to get a heavy bomber off the ground, with a maximum takeoff weight between 264,000 and 330,000 pounds while providing a range of 10,000 miles. An interesting design choice was pairing those pusher propellers with a relatively thick but aerodynamically clean wing. Their goal was to achieve the highest possible lift-to-drag ratio for steady cruise flights. Thinning the wing to reduce drag was absolutely out of the question, as that would have reduced overall lift, required a heavier structure, and penalized both the bomb load and flight range. To keep the B-36 as aerodynamically clean as possible, all equipment and defensive gun turrets were housed internally, deploying only when there was an actual threat. On the outside of the smooth fuselage, only the cockpit canopy, transparent sighting blisters, and radome protruded. This meticulous attention to detail allowed the aircraft's aerodynamic efficiency to approach theoretical ideals usually seen in futuristic flying wing concepts. The massive wing area resulted in a remarkably low wing loading of only about 67 pounds per square foot during takeoff. This allowed the giant to cruise efficiently at high altitudes, requiring minimal power to cover colossal distances. The engines and massive fuel reserves were spread across the wingspan, which took a lot of structural stress off the airframe, saved weight, and freed up a massive amount of internal fuselage space for the bomb bays. engineers fought to shave weight off literally every component, utilizing the latest high-strength aluminum and magnesium alloys. Remarkably, a tenth of the aircraft's metal was magnesium, saving nearly 2,200 pounds off the empty weight. Aviation-grade magnesium was used for nearly half of the outer skin, leading edges, anti-icing systems, and instrument panels. Introducing a new high-strength aluminum alloy saved over 6,600 pounds, while optimizing the landing gear and switching to an alternating current electrical system saved thousands more. Replacing traditional fuel bladders with integral wet wing tanks shed nearly 6,600 pounds, resulting in a bomber where the useful load made up an impressive 58% of the maximum takeoff weight. Let's take a closer look at the unique design features. The aircraft's wing featured a specialized airfoil developed by NACA, incredibly thick at the wing root, to generate massive lift and prevent the wing from twisting in flight. The massive internal volume provided plenty of room for 12 gigantic fuel tanks, positioned outboard toward the wingtips to relieve structural stress. Interestingly, fuel was intentionally drawn from the unarmored inboard tanks closest to the fuselage first to burn it off while safely en route, leaving the heavily armored and self-sealing outboard tanks to survive enemy fire. The wildest part is that the trailing edge of the wing actually housed a crawlway, allowing crew members to crawl right out into the wing during flight to physically inspect the engines. The fuselage had a perfectly circular cross-section with a diameter of about 12.5 feet and a staggering internal volume of over 17,700 cubic feet. This space housed the crew compartments, defensive armament, and gigantic weapons bays. The pressurized flight deck up front and the aft pressurized cabin took up around 3,900 cubic feet, separated by the massive 12,100 cubic foot weapons bays. To navigate between these zones, engineers connected them using a pressurized magnesium tunnel just 2 feet in diameter and 85 feet long. Crew members would lie on a small wheeled trolley and pull themselves along by hand from the nose to the tail of the aircraft. Flown using a purely mechanical cable control system without any hydraulic boost whatsoever, the B-36 featured heavy-duty tricycle landing gear. On the early prototypes, the main struts each had a single massive wheel measuring 110 inches in diameter. This setup exerted enormous stress on runway pavement, requiring a specially reinforced concrete taxiway at the factory that was up to 27 inches thick. Naturally, this meant only a handful of airfields worldwide could support the weight. Therefore, for production models, they wisely swapped these out for a much more reliable four-wheel bogie design to significantly reduce ground pressure. The heart of this giant was the R-4360 engine, an engineering monster with 28 air-cooled cylinders arranged in 4 radial rows spiraling around the crankcase. While early versions cranked out 3,000 horsepower, later upgrades pushed that to a staggering 3,800 horsepower. Each engine was equipped with twin turbochargers, allowing them to maintain massive power output even at altitudes of nearly 35,000 feet. These powerful engines spun massive 3-bladed metal propellers nearly 19 feet in diameter. The propellers featured a reversible pitch function, allowing pilots to apply reverse thrust and cut the landing roll of this massive aircraft by nearly a third. The bomber's payload capacity was incredibly impressive. The giant could haul 2 colossal 42,000-pound bombs, 11 4,000-pound bombs, 28 2,000-pounders, 72 1,000-pound bombs, or a massive payload of 700 and 2,100-pound bombs. Alternatively, the bomb bays could hold 4 extra 3,000-gallon fuel tanks, which could be jettisoned mid-flight. But crucially, this strategic bomber was designed right from the start to carry early nuclear and thermonuclear weapons, with all necessary safety systems baked directly into the design. Designing the defensive armament turned into a real challenge. On incredibly long-range missions, these slow, sluggish bombers couldn't count on fighter escorts. Early radical ideas included fitting up to 3 tiny parasite fighters right inside the bomb bays to deploy and defend the bomber if danger approached. McDonnell Aircraft even built the experimental XF-85 Goblin for this exact purpose. However, real-world testing, dropping the Goblin from a B-29 mothership, showed that recovering a fighter in midair was incredibly complex and dangerous. Later attempts to mount conventional F-84 jet fighters under the wings also failed to produce a truly reliable defense system. Ultimately, the parasite concept was scrapped, and the bomber was equipped with proven, remote-controlled gun turrets, packing 16 20mm aviation cannons, providing 360-degree coverage and leaving virtually no blind spots for enemy fighters to exploit. The crew of the B-36B variant numbered a massive 15 people, 3 pilots, 4 crewmen serving as navigators, bombardiers, and radar operators, 2 flight engineers, 2 radio operators, and 4 gunners. If an exceptionally long flight was planned, relief members brought the total to 18. This group was housed inside the 2 pressurized cabins, with the aft compartment featuring 6 built-in bunks for off-duty rest. The XB-36 prototype went through intense flight testing from late 1946 to early 1947, taking to the skies 31 times and logging 89 hours. These tests uncovered serious design flaws, such as engines severely overheating above 36,000 feet, and harmonic vibrations that would frequently fail engines or shatter propellers in flight. A major emergency unfolded on March 15, 1947, when the right main landing gear failed to extend. 12 crew members bailed out while the pilots bravely remained aboard for 6 hours to burn off fuel and pull off a masterful emergency landing. Following major overhauls and the introduction of the YB-36 prototype, the aircraft finally moved toward mass production. The path to full-scale production was incredibly rocky. The first aircraft from the initial production run was the B-36A. Interestingly, this particular airframe was not supposed to fly at all. It was built strictly for static testing at Wright Field. But an unexpected problem came up. The components of the aircraft turned out to be so massive that it was simply impossible to transport them overland using any available road or rail network. Engineers had to make an unconventional choice. They made this test article flyable just to deliver it. On August 28th, the airplane successfully made its very first flight and was ferried over to Wright Field to undergo a grueling testing program. It wasn't until 1948 that Convair started assembling B-36s at a steady pace of 2 to 4 airframes a month. Realizing they needed to speed things up, the Fort Worth plant dramatically expanded its workforce from 7,000 to over 18,000 people, and by April 1949, they had rolled out 54 bombers. The financial cost of this program was astronomical, reaching about $1 billion by August 1949. Under the initial order, each B-36B cost nearly $4.7 million, but with added turbojets and upgrades, the price spiked to $6.2 million before finally settling around $3.77 million for the final B-36J variant. The Fort Worth plant churned out 68,000 unique parts for every single B-36, feeding 8,500 pre-assembled components onto the line every day. The first early B-36A models were primarily used for training, showcasing their capabilities in marathon flights. In April 1948, a B-36A flew nonstop for 32 hours, covering 6,100 miles and successfully dropping a 10,000-pound bomb load. By mid-May, fully loaded with defensive armament, it flew an incredible 8,000 miles in 36 hours. In June, crews tested the maximum payload capacity, dropping a massive 84,000 pounds of bombs, including 2 42,000-pound bombs, during a single mission. The first fully combat-ready variant accepted by SAC was the B-36B, featuring 16 20mm cannons and 3,500 horsepower engines, pushing its top speed to 381 miles per hour. It became the primary carrier for the first American Mark 17 thermonuclear bombs, which weighed in at 44,000 pounds. However, as Soviet air defenses introduced the transonic MiG-15 fighter, the B-36 needed to fly faster and higher. After an ambitious design for a B-36C with compound engines failed, engineers came up with a brilliant solution, mounting 4 auxiliary turbojet engines under the outer wings. Starting with the B-36D variant, 4 General Electric J-47 turbojets were packaged in twin pods suspended on pylons. This 6-turning and 4-burning configuration dramatically improved the takeoff run and pushed top speeds over 400 miles per hour. At the same time, Convair set up an assembly line for the heavily equipped RB-36D reconnaissance variant. Packed with up to 23 massive aerial cameras, 80 photoflash bombs and state-of-the-art electronic intelligence equipment, the crew size of these recon planes was expanded to 22 personnel. The final production version of this giant was the B-36J bomber, which increased fuel capacity and pushed the maximum takeoff weight to an incredible 410,000 pounds. To maximize performance, the Air Force implemented the ambitious featherweight program on the last production batches. By cutting the crew down to 13 and stripping out almost all defensive gun turrets, leaving only the tail turret, the bomber's empty weight was slashed from 180,000 pounds down to 166,000 pounds. This diet increased the combat radius to nearly 4,000 miles and allowed the airplane to climb to an impressive 47,000 feet, making it exceptionally difficult to intercept. To keep this massive 10-engine combination fed, they pumped a staggering 36,400 gallons of fuel into the tanks. Operating a giant like the B-36 demanded razor-sharp skills and entirely new logistics. A standard ground crew consisted of 30 specialists. Because standard ground support equipment, or GSE, was completely inadequate, engineers had to design specialized gear from scratch. To load super-heavy bombs, they developed unique electro-hydraulic bomb lifts capable of handling 50,000 and 22,000 pounds, hoisting weapons 12.5 feet into the air with pinpoint precision. They rolled out monstrous all-wheel drive tow tractors to get the mountain of metal moving, and built prefabricated clamshell hangars and mobile maintenance docks so crews could service the aircraft outside in brutal weather conditions. Despite its size, the B-36 proved to be a fairly reliable aircraft, dubbed a pilot's airplane by crews because of how surprisingly forgiving it was on the controls. However, the fleet did suffer tragic accidents, such as a 1953 disaster near Newfoundland that killed 23 crew members, including General Richard Ellsworth. The fleet took its hardest hit on the ground when a fierce tornado slammed into Carswell Air Force Base in September 1952. Damaging over 70 parked B-36s, half of all the B-36s in the SAC inventory at the time, requiring monumental repair efforts. Throughout its service, the B-36 survivability was fiercely debated. In July 1949, during the Revolt of the Admirals, the U.S. Navy sparked a congressional investigation, hoping to divert B-36 funding into building state-of-the-art supercarriers. Naval leaders heavily criticized the bomber, but Air Force officials, including General George Kenney and General Curtis LeMay, successfully defended the program. Tactical tests demonstrated that even American F-86 Sabres, fighters comparable to the Soviet MiG-15, struggled immensely to intercept the B-36 above 40,000 feet. The fighter's turn radius at that altitude was so massive that a slight turn by the bomber completely broke the attack profile, making the B-36 practically untouchable by the radar networks of the early 1950s. During the Cold War, B-36 squadrons immediately took to the skies whenever tensions flared, deploying to forward operating bases in Guam, Okinawa, Alaska, and Thule Air Base in freezing Greenland. However, the greatest threat to the B-36 was the relentless pace of technology. While it successfully served as America's ultimate nuclear deterrent, standing on continuous alert without ever dropping a bomb in combat, the arrival of supersonic interceptors and surface-to-air missiles signaled the end of its viability. By 1955, the U.S. Air Force began taking delivery of the sleek, all-jet Boeing B-52 Stratofortress. As these swept wing jets arrived, the piston-powered giants were gradually phased out, with the final aircraft retiring on February 12, 1959. It is worth mentioning that the story of this aircraft did not end merely with mass-produced bombers. The B-36 airframe served as a vital testbed for a series of wild experimental modifications. In 1950, engineers even evaluated a bizarre tracked landing gear system to disperse its immense weight. The ultimate evolution came with the creation of two unique YB-60 experimental airplanes, which featured swept wings and were powered entirely by 8 turbojet engines. While designing and testing these variants, engineers tackled a massive range of complex challenges. That hands-on experience became absolutely fundamental for the future development of strategic aviation, closing the chapter on the piston-powered superbombers and laying the groundwork for the jet age.